Hello guys, and welcome back to another class of our course about the complete introduction to data science. Basically, in today's class, we are still talking about some statistical concepts, and one of the most important statistical concepts that is very used in data science is called decision trees. So once again, we can make a full 45-hour course about decision trees, but my goal here is not to, create a full course about decision trees and talking about all the mathematical concepts that are around decision trees, but just to give you guys a brief introduction so you will understand that it works, that it's really present into data science, machine learning, as well as all the things that are around those concepts. Alright, so basically what exactly is decision tree? So if we talk about ourselves, we have a brain, and let's say we, for example, want to make a decision. So our brain is a huge computer. And let's say, for example, our brain wants to make a decision. So our brain will automatically create a decision tree. Once again, it's not gonna be like it looks like this. It's gonna be more different. And the brain will say, okay, if I make this, I will have this outcome. Or if I make this, I will have this outcome. For example, let's say you have the choice between eating healthy and eating, I don't know, a pizza, for example. So your brain will say, okay, if I eat healthy, what will happen? So the outcome, for example, if I eat healthy, I will be, I don't know, I will build muscles. If I build muscles, this will happen. If this happens, is it good or bad? Okay, it's good. Okay, if, for example, I eat pizza, what's gonna happen? Okay, I eat pizza, I will be satisfied right now because I just ate pizza. And once again, I will be happy, but what will happen in the long run? Okay, if I eat pizza, I will be happy, but after that, I won't be happy anymore because I won't be in shape, etc., etc., etc. So basically how we can see decision trees, those are simply diagrams or charts that people use to show statistical probabilities or to determine the possibility for an action to happen. So basically you can see it just right here. So once again, I tried to find a very simple decision tree. So right here we have an example. So let's say, for example, A is lower than B. So if yes, then B is lower than C, and etc. And at the end, this would be our question. And we will be able to find out an answer that looks something like this, just with yes and no's. So at the end, with A is smaller than B. If it's smaller than B, we can say at the end that A is smaller than C, it's smaller or equal to B. Or C is smaller or equal to A and smaller than B. And same thing right here, if for example B is greater than A, this could be our outcome. So the main goal right here is really to go from having a question that we ask ourselves to an outcome that we will have at the end. So basically the best outcome would be one of those, and the best outcome usually comes with there are mathematical formulas that we'll talk about a bit later in this course. We'll not talk really in depth about them, but just to give you guys an introduction to this. So as I said, you will have you will have this that needs to be resolved, and it's resolved by using mathematical formulas and by building up decision trees. So like here, for example, we have a decision tree, and the decision at the end is done with the mathematical formulas. For example, we have entropy that will be calculated, and we'll have some other things that will be calculated as well. So if we stay in decision trees, once again, we can have some decision tree examples right here that I found. Once again, those decision trees examples are pretty simple, just for you guys to understand what a decision tree is. So right here, for example, is a person fit? So if the person is lower than 30 years old, if yes, does it eat a lot of pizza? Yes, then the person is unfit. If no, then the person is fit. Same thing right here, is the person higher than 30 years old? Well, no. Is the person exercising in the morning? Yes, then the person is fit. If no, then the person is unfit. Once again, this is really simple. Even the decision tree right here is pretty simple. Usually you have way more variables, and it's way more calculated. It's way more hard to calculate everything and find out the best combination. But once again, this is just a small example of what you can find if you work with decision trees. So basically your brain does this automatically, so you don't even think about it. Your brain does this automatically when you have to take a certain decision. It could be basic decision, for example, I'm walking or I'm driving, I will turn right or left. Or it could be more complex decisions, for example, when you are sitting at a certain exam and you need to write down an answer. All right, so the mathematical aspect of all this, basically there is a lot of variables that can be calculated, but personally, I think there is two very important formulas that we will talk about right now. Once again, you don't necessarily need to understand them 100%. This is just an introduction. So the first one would be the formula of entropy. And basically, entropy will be used to calculate the homogeneity of a sample or the impurity of a database. So basically, usually entropy is used when you work with the databases and you build up your decision tree with those databases. What you need to understand is that if entropy is 0, the sample is homogeneous. So like this, for example. And if entropy is 1, it's equally divided. So everything is equally divided. What's important also to understand is that entropy is somewhere between 0 and 1. It can be higher than 1. Usually it's between 0 and 1. Also, entropy is very important to make the second part of our calculation because it controls how a decision tree will decide, well, how a decision tree decides to split the data and will have an effect on how the decision tree will draw its bases. So basically this would be for entropy. So the entropy is the first part of the calculation. And after that, we have another part that is very, very important, which is the information gain. So entropy help us after that work with information gain. So information gain would be another mathematical calculation that we will make to be able to choose the right path to take inside of our decision tree. So here is our information gain formula. Basically, it looks a bit complicated, but it's pretty simple. Right here, we have our complete entropy. So basically, the whole entropy of the whole decision tree. And here we'll have, for example, the entropy of the left side and the right side, for example. Usually, the calculation is a bit more complex because you have sums of all entropies. But and this would be the entropy of the whole decision tree. But once again, this is with just one left and one right side. But what does information gain? It will give us how much information a certain variable give us about the outcome. And to interpret it, it's pretty simple. So a high information gain allow us to create a decision tree that will be more representative of the results that we expect to have. So basically, if we come back to our decision tree right here, and let's say this outcome right here has an information gain of 0.9. Well, this would be the outcome. This would be the decision tree and the outcome that we will look for. So basically, the higher the information gain is, the higher this would be the decision part of the decision tree that we will take, because the results will be more representative of what we are looking for to have at the end. So besides of that, those are the two formulas that are pretty important. So we have the entropy and the information gain. But in all this course, what I want you guys to understand is the concept of decision tree. So this is a really, really important concept to understand. The mathematical part, once again, you are not professional right now, and it will take time for you guys to understand it as a whole. But the concept of decision tree, as I said, it works pretty much as the human brain. So basically, when you want to make a decision, you will automatically create a decision tree inside of your head. You don't even need to think about it. And this works pretty much the same way. So for example, if you are building up a certain algorithm that, well, not an algorithm, but let's say, for example, you're building up a machine that will think by itself. What you will add to it, you will add an algorithm that will learn by its experiences. So it will try, for example, something. So I don't know, you wanna create an algorithm that will identify faces. So you will give to this algorithm, I don't know, 100,000 faces, and this algorithm will work. Will see how each face, what each face looks like, and it will learn by itself. And after that, when you will give a face to this algorithm and tell him, okay, is that a face, yes or no? And what the algorithm will do, it will build up a basic decision tree to be, well, it will be more complex than the basic one, to be able to tell you at the end if this is a face based on variable 1, 2, 3, 4, 5. So it will test some things, for example, number of pixels, number of, well, a lot of things. It will test a lot of things, but at the end of the day, it will have a certain decision tree to be able to tell you, yes, this is a face, or no, this is not a face. This is, I don't know, for example, this is a water bottle, for example. So I hope you guys understand the whole concept of decision tree and the two formulas that comes with it. So that's it for this class, guys, and see you all in our next class where we will still talk about some other statistical concepts.